Let's look at an example. We've got a set of data that's for the winner and the runner-up, and we want to compare their heights, and we're asking, is there a linear correlation? Okay, so we're going to plot these as our x's and our y's. So we'll start out with our winners as our x's and our runner-ups as our y's, and we'll plot those as our data. So that means our winners x1 will get plugged into our list 1 as our x's, and then our runner-up information will get plugged into our list 2 as our y's. Just like before, how do you do that? You press your stat key and then select enter, or select your stat key and then press edit by pressing enter. Then once you have all your data in, then we will continue along, press the stat key one more time, but this time go all the way over. Instead of being at edit, we're going to go over to tests. And what we're going to do is we're going to go all the way towards the bottom of our list, and we're going to select a Linreg T-Test. What this Linreg T-Test, which is option F on my calculator, is it's shorthand for what's called a linear regression, and it uses a T-test to do this. And again, why is it doing a T-test? Is because we have a set of data and we don't have sigma. The linear regression means it's trying to make sure whether or not it looks like a line. So we'll do the Linreg T-test, and then just to give you an example of what should come out of your calculator once you run your Linreg T-test is what comes next. So your Linreg T-test should display the whole list of data. You might have to actually press the arrow down button to see all of the numbers listed. Now, however, these last two values your calculator may not automatically display. If your calculator does not display these values, then you need to listen to this next part, because you have to turn on this diagnostic and it will make these two numbers appear, which are really important. We're going to use these two numbers. To make these two numbers appear, and again, you should only need to do this once, you will go to your calculator, you'll press the second button first, followed by the 0 button, which is actually the catalog key. And then you'll want to go all the way down to the D's, keep scrolling until you get to diagnostic on. And you want to select that option and press enter. And it's going to run a program that's basically going to turn on displaying your R's. Now, if you go back and do your Linreg T-test, you don't need to re-enter your data. It's already there. But if you run the Linreg T-test this time, if it wasn't displaying it before, it should now. You should see an R squared and an R. The only one we're going to really care about, though, is the R. That is your correlation coefficient. That's what we're mainly going to use in Chapter 10 here, is this correlation coefficient. Now notice, this correlation coefficient of negative 0.0086, that is very close to 0, which means, well, what does it mean if our correlation coefficient is really close to 0? It means our scatter plot is going to have no correlation, which means it's not going to look like a line of any sort. It's just going to be a bunch of scattered out points. And if you wanted to, you could graph it just like we did before using the plot feature. Now, if you want a formal way to actually test a claim of linear correlation, a formal way to test a claim of linear correlation is going to be using P's and alphas. If you noticed, our Linreg T-Test can give you a p-value. So what we would do is the same thing as before. You're asking, is p less than or equal to alpha? The question doesn't change even here. If the answer is yes, though here's where we're going to change, then we'll say that there is sufficient evidence to say that there is a linear correlation. If the answer, however, to is p less than or equal to alpha, if the answer is no, then we're going to say there's insufficient evidence to say that there is a linear correlation. Notice, this is not saying that there isn't a linear correlation. What it's saying is that there is, keyword, insufficient evidence to say it. It's like saying the test is inconclusive. You're not saying there isn't, you're just saying there's not enough evidence to say that there is. This is the exact same idea as rejecting and failing to reject that we had back when we did hypothesis testing. So let's do an example.